So, hello everyone. Welcome to this webinar in the Iliad webinar series. Today, the topic is interoperability, the role of best practices and standards. My name is Bente Lilja Bye. I'm going to be your host today. And with me, you see, I have a panel of experts which will give some information around the topic of the day. They will introduce themselves as they are starting their presentations. A little bit of housekeeping first. Please mute yourself when you are not speaking, and do use the chat. So while you hear people are asking, you have questions, please do comment or even comment and ask questions in the chat. We will be having a discussion. Hopefully we will have time for that. That's the plan, to discuss after the presentations. Now, we also have something, some polls that we want you to answer and engage in. During each of the presentations, you will be given a poll that we ask you to answer, and some of the results will actually be inspiring some of the discussions afterwards. I will share the results of the polls between each of the presentations, so please do participate in the polls. With that, I think I will start the program, and with that I will share my screen. First, to remind you of today's program, you see we start with a short introduction of Iliad Digital Twins. Then we will talk about best practices and standards support to interoperability by Pearlman. Moving on to piloting an information management framework for environmental digital twins by Justine Buck. And why are the development and adoption of standard instrumental to digital twins? That will be covered by Marie-Francoise Voidrot. We move on to citizen science. Is citizen scientists' training relevant in achieving data quality and interoperability by Luigi Ceccaroni? And last but not least, OceanPractices, building inclusive best practices and standards by Rebecca Zitoun. Sorry for the pronunciations. You will correct me gradually here. So first, this is an Iliad Digital Twins a webinar series. And first, I would just remind you about the concept of digital twin. A very simple version is that it's providing a virtual environment representing the ocean, capable of running complex predictive management scenarios, and also state-of-the-art current situation, maps. And the innovative system integrates across many disciplines, and this is why interoperability is key, by the way, sensors, models, and various infrastructures. So you see here some examples of how that might look like. In Iliad, we have sort of three pillars, Iliad in the seashell here. First of all, we are enabling an ecosystem of interoperable digital twins. So there are multiple twins, and we are connecting with existing infrastructure as well as providing new information and facilities, including, again, citizen science. To make this accessible for multiple users, we are creating a marketplace. And we have then developing innovative methods and frameworks for this. And we can also do evaluation and comparison, etc., via this marketplace. And final but not least, we are providing actual solutions to some of the challenges that we are facing related to the ocean. So those are the three pillars in the Iliad Digital Twins of the ocean. Here you see, just to illustrate that there are so many different disciplines and types of activities related to the ocean. We have renewable energy, like wind farms, coastal sediment transport, jellyfish, which is a citizen science project here in this case, activities related to the coast, fisheries, aquaculture, insurance, etc., etc. So there are multiple thematic and local twins to be developed in Iliad. this is a Horizon 2020 project under the Green Deal. And you see here that we are quite a few partners, 56 partners. We are running for 3 years. We started in February 2022. It's a massive investment in total, almost 19 million euros in total. So with that, I will start the first talk. And Jay, I give the floor to you. Can you introduce yourself and let us hear what you have to say?
Thank you, Bente. And it's a pleasure to be here. I'm Jay Pearlman, and I'm working in Iliad on a task to collect and help develop, facilitate best practices and standards in Iliad and digital twins in general. Also, I've been part of the Ocean Best Practice System, and we'll discuss that later. So with that, I'd like to start my presentation, which is best practices and standards support to interoperability. There are 3 parts to the presentation. I'd like to start talking very briefly about what is interoperability, what are best practices, and what are standards. Later in the webinar, Marie-Francoise will talk about standards and Rebecca Zitoun will talk about best practices. So there'll be more details as we go along. And then finally, I'd look at the best practices for systems and the components of digital twins. And here, although I know we're focused on digital twins of the ocean, digital twins have been with us for some time in industry, in government support, etc. And so I do take a slightly broader view than just oceans in my discussion as we move forward. So let's look at the definitions. Interoperability in ocean research and applications is fundamental for advancing our knowledge and really involves standardizing technologies, data and analysis methods. So that'll be the theme of the discussions today. And if we look at standards, a standard refers to a documented set of guidelines and specifications. What's important is that standards provide a common foundation of practices and requirements. And from that, you don't have to reinvent the wheel each time. You can innovate beyond the assumptions that are provided through the use of standards. This is very, very important as we move forward with digital twins. Best practices are methodologies that have repeatedly produced superior results relative to other methodologies with the same objective. This is a definition that came out of a paper we wrote for Ocean Ops in 2019 and from the Ocean Best Practice System Steering Group. There's always a debate between a method and a best practice. So for best practices, we view that as a promising method that's been reviewed and adopted by multiple organizations. So what is the difference between best practices and standards? Best practices generally evolve from individuals, from organizations, research organizations, or application areas. And they document the methods, and eventually these transition to best practices, endorsed practices, and standards. Particularly endorsement by a panel of experts becomes important if there are multiple practices for the same application, whether it's measuring oxygen, temperature, or other things in the ocean, or the biological components. Standards are generally created through a defined process under standards organizations. OGC is a good example, IEEE, and others. And actually, once the standards are documented, a series of practices are developed for their implementation, and those end up being best practices. So if I had to say that these are really two aspects of the same need to support interoperability. Best practices and standards work closely together. Okay, let's turn now to digital twins. This is a figure that comes from Martin Wiesbeck and the Ditto community, and it's looking at the definition as a virtual representation of a real ocean, and actually it's a mirror of what the nature is, for our case, the environment. And the observations from the real ocean then are put into the digital twin. And as changes occur, the digital twin can do what ifs. There are a number of digital twins evolving, digital twins of the ocean. One is eDitto, which is a European funded project. And it consists of a data lake where data is stored and can be processed, and a digital twin engine, which brings in various models, artificial intelligence, and other capabilities. And bringing these together, you can then begin to address a simulation and a replication of nature. Let me look at two of them. There's a third one that I'm not going to address in detail, which is being developed in the UK, and Justin Buck will be following me in this presentation, and we'll discuss some of the developments in the UK. And so let me focus now for a moment on eDitto and then on the Iliad Digital Twin. We see here a diagram which Marino Tononi has provided me, and I thank her for that, in which we see three major elements. eDitto has a data lake where data is stored and a data catalog that goes with that to be able to select data. It has an infra engine, which is a process registry, computing clusters, and support basically of the processing that needs to be done. And then there's the infra services, which is both a catalog, a virtual research environment, various tools, and an interaction with the users. And there are various APIs that join the support and the part of eDitto to make it practical. Turning to Iliad, there's a little more detail in this, but as we see, we have data sources and data providers. The data providers in this case can be the various, let me just get rid of the poll here, can be either research organizations, open system providers, commercial systems, and basically distributed twins. So there's a variety of inputs. Right now, the eDitto is focused primarily on EMODNet and the Copernicus Marine as sources. These are sources that are pre-digested, if we want to call it that. In Iliad, because we're looking at a number of very different digital twins, we're looking at different types of data coming in. That goes into a data service catalog, and you'll see continually comments on semantic harmonization and data lakes, which is embedded throughout the system. And then we have the digital twin, which consists of various application services and modeling. To make this diagram easier to understand, we can just put categories across the layers so that we can see that what the digital twin consists of, not unlike eDitto, are data sources and providers, the catalogs, the data space to store and use the data, and then the digital twins in the front end for the users. So that's the construct that we're looking at for it. And I want to move now to a diagram that maybe is a little more colorful, in which we're looking at the constructs. And here now I'm referring to not only the digital twin of the ocean, but a lot of this comes from the broader community of digital twin creators. And so we have a core, which is in gold. The green is the tools that are brought in, and the cloud environment is shown in gray. We start out with the basic architecture. Here we see best practices, methods, and standards are part of a foundation for all of the activities that are going on here. We have the data transformation and a data lake. In the case of eDitto, because the data comes from eNOT, Net, and Copernicus, and it has metadata that's been standardized, that doesn't need to go through transformations, but can go directly into a data lake and then the DTO engine. In Iliad, there's multiple digital twins that we're going to interface with, as Bente said. And so there is sometimes the need for data transformation and, of course, putting that data into the data lake. For conventional, if I may use the word conventional, or for industrial type digital twins, data lakes really are raw data. And I'll talk about that in just a minute. I would say that other than that, the marketplace, which Bente talked about, is an important access for users, the idea being to support a broad community. I'd like to turn now to the question of interoperability and how it fits into this. Interoperability is layered. There's interoperability related to the entire system. There's interoperability related to the exchanges between various components or elements of the system. And there's also interoperability and best practices relating to internal components such as the data lake. And so let me talk about two of these, first at the system level, and then I'll talk about data lakes. There's a series of things, best practices that need to be implemented to make a practical system level digital twin. Defining clear objectives is something we tend to not focus at the beginning, and we pay for that in the end. And so this is the place where we want to have, who are our customers? Who are we supporting? What type of resources do we have available? And I can go through the rest of these, but let me emphasize that the digital twin has to deal with raw and processed data and be scalable. As we work with industry and other groups, not the open research environment, we need to deal with privacy, we need to deal with intellectual property and data governance. Security is important overall and needs to be addressed. Going to the data lakes. Data lakes are really a storage repository, and the emphasis in the broad community of this definition is that they handle large amounts of raw data in native format. So they can be either videos, they can be traditional type of digital data, etc. And then the digital twin draws on this raw native format to do analysis when it's called for by various users. So the characteristics we're looking at is open to all data. It's stored in untransformed state, and the data is transformed only when provided for analysis. This is not necessarily true for the ocean constructs we're doing now, but is a more general definition. And as they like to say, without best practices, data lakes become swamps, data swamps. Let me turn now to the best practices. These are very similar to the ones that we see in the system level. And I would just emphasize that we also need to deal with various security issues such as backup, disaster recovery, and a logical structure that we can easily get access to data. So we've heard a lot about or at least a little bit initially, about the data and the best practices and standards that are needed for the digital twin of the ocean. And what we really need is a way to provide those best practices and standards to the community, making them accessible. And that requires they be in a repository of some sort. The Ocean Best Practice System does provide this function for Iliad, and it also sustains methods for the ocean information system. Rebecca will talk a little bit more about the OBPS in the presentation later in this webinar. And I would just like to comment that OBPS collaborates with IEEE, who will be addressing system level standards for DTO, and with OGC for interface visualization and data standards. And Marie-Francoise will talk about those. So in bottom line is that standards and best practices facilitate trust, interoperability, and inclusiveness. And all of these rely on creating and using documented standards and best practices. Thank you very much.
Thank you, Jay. Thank you. An inspirational start on today's webinar. I promised you the results of a poll. Thank you, everyone who were participating. I will end the poll now and share the results with you before we move on. You just end. So the question was, at what level system or subsystems of components are best practices most important? And the question is then, I would like to use best practices, contribute to best practices, collaborate to develop best practices, and not quite sure. And you see that both collaborate to develop best practices, Jay, this is inspiring results, and also use the best practices. And some will contribute to best practices. And quite a few will probably be convinced by the end of this webinar to contribute to best practices. Thank you, everyone, for participating in this poll. We are moving on to the next speaker, which is Justin. And yes. And for you as well, a short introduction to yourself, and then you can go ahead and talk about your topic. The floor is yours.
I'll just find the screen to share. I apologize for any noise. I'm next to a building site and they've decided to get busy.
We don't hear it yet, anyway.
That's okay. That's good news.
Yeah.
That should work. And then should go full screen, hopefully. How's that?
It's the next slide version. You need to choose another.
Full presenter view.
Display settings, maybe, or I'm not quite familiar. I see very often you get this kind of.
Just got to flip present view.
He's got two screens, probably.
Yeah, I can fix that. I know I'm on screen. Yeah.
Yeah, too many options. Still, yeah.
There we go. That's better.
There you
Okay.
go. Yes.
So my name is Justin Buck. In the context of this work, I am representing the Digital Ocean Group in the National Geography Centre. And it's the work of many. You should see I've got quite a long collaborators list. And I'm going to be presenting kind of the story of the last 18 months, where we've actually been working on a couple of projects to scope and understand how to begin to develop digital twins. So in terms of what I'm showing you, I'm going to give a very brief introduction. What is an information management framework is a key question to begin with. And then I'm going to show the results of two projects, one which we ran only had 6 months, about scoping what this framework is. And then the one which we're about to come to end to in 2 or 3 months' time, which is about doing a pilot for that and showing if that's possible. So in terms of an information management framework, I present this to quite generic audiences. So our generic kind of definition to kind of get past some of the ambiguities in people's different definitions of digital twins we treat it as virtual representation of a physical asset, enabled through models and simulators, real-time prediction, optimization, control. And the key thing is the work that we do needs to generate improved decision-making. And there's a key concept that's introduced in the first project, which is what we call an information management framework. And it's about, when you develop a digital twin, getting a shared vision, building a conceptual framework to build those twins. So Jay's presented a conceptual framework just now. Agreeing and implementing a digital commons, which is your approach and this kind of concept of narrow middle to develop digital twins to keep it effectively user-focused. Delivering demonstrators to show the value of the work you're doing, and actually developing those components. And the key thing with this is that use cases bit and kind of a little visualization of what that information management framework looks like is on the right-hand side. So you can see you've got key things on the left-hand side, like management and governance. We've got our pilot studies. And then we've got the components, the twins on the right-hand side here. And that's effectively the result of our first project, which actually looked at 3 different use cases for digital twins in the UK and scoped those requirements for how to develop those further. So we looked at something called 3DT, which was a dispersion model in the atmosphere by the Met Office, used to effectively project forecasting and information needed when you've got atmospheric pollution events. It can be anything from kind of smogs to disasters where you get, or incidents where you get kind of plumes emitted from fires or chemical works. We've got one called Land Insight, which effectively is a carbon and soil moisture digital twin for soil. And that can feed into things like decision-making for along railways or around infrastructure, through to information for IPCC and climate change. And then a big one for us was the Antarctic digital twins, which have been developed by British Antarctic Survey, and they're developing a digital twin for their new research vessel, Dave Attenborough, which has the surrounding twins for the sea ice and for the Antarctic. And it's to optimize observations taken by the vessel and to do things like and reduce the amount of carbon needed, because you can optimize the pathways for the vessel. And we found that you needed different levels of interoperability across these 3 different twins. So you potentially the meteorological information shared between the Met Office and British Antarctic Survey, and also between CEH, but you don't need the kind of systems level information supplied between the 2. So based on use case per use case, you need different levels of interoperability between the different types of events. This enabled us to scope a set of recommendations. And at the top level, we took top level information from the Centre for Digital Built Britain and the theoretical landscape and the environment domain. We brought that with the use cases, and then these bits at the bottom are the technical components, which I won't go into detail because I've got time. And that produced this report, and there's a QR code here if you're interested in those recommendations. And they're now forming the basis for calls for future with further development of digital twins in the UK at the moment. So the second project, which we started about 12 months ago, was piloting this information management framework and seeing if it's possible and trying to develop the first components to see how they come together. And this is what the project looks like. Key thing for us is stakeholder engagement. So we've actually got a senior stakeholder forum of senior representatives from institutes across the UK. We've got the framework, which is the frame, and we're about to publish this. So we actually got the paper in the near final version, which we're about to publish. Services. So these are the elements of that kind of information framework. And I'm going to show you something called an asset register, which is the first one we developed. And that is effectively a description digital twin that enables us to share information across digital twins and share descriptions. And then we actually want to demonstrate this as a real twin. So we're actually building a twin for Hague Frass marine protected areas just off the coast of the UK to look at biodiversity. And these all get brought together across different work packages, feedbacks between them all. I'm going to show one slide on the Hague Frass because I want to get to the interoperability components. But this is effective. This is the use case we're using. It's effectively a part of the G7 presidency. It's a priority, and it's looking at the biodiversity of the Hague Frass marine protected area just off the southwest of the UK. And if you effectively you've got a digital twin of images, so we use autonomous vehicles with cameras on them to survey the area. The goal is once per year. Those images can then go into a twin. We can run AI and machine learning across those images to actually do surveys for the biodiversity. And there's a proposal in at the moment to develop that AI machine learning component. The results of that can then inform just close the poll, can then inform policy and reporting to government, and they can also inform future surveys. Coming back to the interoperability component, the key element we've developed is something we call the asset register. It's effectively a description based on, it was formerly a data catalog, and it describes a digital twin. So it means you can include information around things like this, the ontologies that underpin it, the best practices that underpin it. We've built it on top of linked open data. That's our base standard we've used. You can include elements for visualizations, the code that you're using, the data that's actually in that twin. And I'm going to flip screens. Hopefully this works. The screen. This is the prototype asset register. It's not complete yet, so you can see it's only got data sets, services, and software in it. In effect, it's a register of assets that you can explore. And if you click on an asset, you can see it's got a fairly generic, it's got a description of the asset, and then the downloadable information. And this gets then effectively, because we've got linked token data on the end of it, it follows standards like DCAT. And we also want to put the I lost my thread. We also want interoperable view and decade and the ODIS network. So effectively, if we get it to ODIS, we can actually share it with the Ocean Info Hub. And the standard to do that we want to actually get on top of that is schema.org, which they use. So effectively, we've got a register of assets. This will fully describe the twin, everything from what's in the twin to the twin, which we can expose to the web to make that discoverable. And when anybody's interested in our twin, the digital twin that we've got, they can actually come to the catalog, they can explore it, they can find out what records they are, actually look at those components, and then potentially we can share the information. So it's actually that interoperable description of the twin. And flip to my last slides. So that's the asset register, keeping, and we're in the final stages of actually creating that and actually exposing that to the web so people can explore it. The other key element we've got is a senior stakeholder forum. We created the forum to actually ensure that we get requirements from organizations across the UK. And there's been 2 or 3 meetings with the key outcomes. And the key thing I really want to show on that is the outcomes that come from senior stakeholders in the UK. And that is interoperability central challenge of the work that we're doing. Imposing standards may not be possible, but through common applications, common standards may emerge. And the asset register they see as a good example. The user needs to direct priorities. This is going back to the use cases and actually working on high priority use cases. And they want small and fast rather than big and slow. So they're putting us actually a series of short projects. The next projects we're bidding into at the moment is another 12 to 14 month project. And we're actually having the next meeting in October this year, and we're exploring the concept of communities of practice because I see this as a key way to share standards across the communities. And that's the slide deck I've got. I just want to show one more slide to you, and that's a key thing from the UK that you may not be aware of in this community, and it's the Turing, Alan Turing Centre has started the Turing Research Innovation Clusters. There is one for environmental digital twins. And they're going to be a keynote for us in the UK in sharing practices and developing practices together. And they're likely to be our facilitators for actually developing these practices and sharing them with the community. And that's what I have. Thank you.
Thank you very much, Justin. I posted, unfortunately, the poll a little bit early before we saw all the assets categories, okay. But I saw people were waiting a little bit, so they got to think a little bit before they answered. So here you see the results of the poll. Do you see the value in the asset register concept that Justin presented? And yes, 2 yeses, and somebody, and actually most of these are actually doing something similar already, which bodes good for collaboration and interoperability in the future. And we also have somebody who is interested in learning and exploring more of the concept.
That's kind of a really positive result, because the next question is, as a community, how do we bring these efforts together to actually make sure that we can work together on this?
Yeah, excellent. So thank you very much, Justin. And now we are moving on to see, to learn more about standards. And if they are, the question is, why are the development and adoption of standards instrumental to digital twins? Marie-Francoise Voidrot will do that. Marie-Francoise, can you introduce yourself shortly and then get on with it?
Sure.
Floor is yours.
My name is Marie-Francoise Voidrot. I'm a Europe Director with the Innovation Program with the Open Geospatial Consortium. So I will introduce a little bit the consortium and the innovation program while I will do my presentation. And I would here try to convince you why the development and adoption of standards instrumental to digital twins. So what is OGC? It's a forum for thought leadership to drive innovation and standards for anything related to location. And in fact, everything is located, everything happens somewhere. So the location is the key to reach for this capacity of interoperability to merge and combine data together. And what we consider our mission is really to make location information findable, accessible, interoperable, and reusable, fair. So findable, accessible is quite clear. Interoperable, we have mentioned that before several times, but I will give you very briefly why it is important. And reusable, this is really the goal, to reuse and reveal all the value of the work we do. And our approach is to really to build an agile process to combine consensus-based standards. Consensus is very important in the definition of standards. It's something which have been agreed. I will come back to that. And we have an innovation project, and I'm attached to this innovation project to try to build solutions based on these standards. So Earth observation and ocean is part of that, require pluridisciplinary skills, and the standards enable to make the data and processes more findable, accessible, interoperable, reusable. As said before, this is what OGC is working on, because what we need to merge is big data, technology, science, skills, and policies. And you need all these components, and you can consider that standards is part of technology, but for some people is a science, and you need some skills, and the policies can recommend standards. So in fact, the goal of the standards is to reduce cost, because you can do anything without standards, but then it will be very costly because you have to reinvent the wheel all the time. And what the standards will reduce cost, improve efficiency, mitigate the risk, because if you have some component, some provider that disappears, you can replace the component, improve speed to market, increase customer trust, work across borders, and supports inclusiveness. This is something I have just added listening to Jay, because this is very important. With standards, you can work with components that come from big companies, small companies, rich countries, developing countries, much more easily. So we tried here to bridge the gap between to explain why standards are really instrumental to digital twins. And in fact, a digital twin, as said before, it provides a virtual environment representing all the ocean and the complex running processes and scenarios. And we need to do that across the different disciplines, and as said before, but also across the different sciences. So I took this slide from a presentation from Bente, but in her presentation, it was reversed, because as we need to build a digital twin, we need interoperable, data-intensive, and cost-effective solutions. But I think that the concept of digital twins brings a global shift from data-centric past, where we work a lot on catalogs and making data accessible, interoperable. And now we try to build some systems which are much more user-centric. And this is supported by the FAIR and the geodata management principles enabled by standards. We can now hope to build systems that will really solve the problems from the user. And this is very needed because, for instance, of the impact of climate change that require to build complex scenarios and address questions through the different sciences. So what is interoperability? If you have some pieces which are not interoperable, this is compatible. These are incompatible. You don't have anything you can plug together. If you build specific plugs to connect the systems together, then these are compatible because you have invested a lot of time in making the plugs. When you have some standards, this will be interoperable. It's not as easy because you only have one standard. You will have several standards depending on the type of data and depending on the systems or where you want to work, but it will go towards this direction. And this doesn't mean that everything has to be free. You can have patents, you can have protections, you can have business models, and you can sometimes have some extensions or evolutions. So it's type of almost a standard, but not completely, but you already save time. And when you work on interoperability, you have to consider it as input, because I need interoperability to get more data in my system, but I also need to be interoperable with other systems. So what is interoperability? Very often you need to combine data that come from different sources, same type of data, but from different providers. And here you will need some standards for the format. For instance, most of you use NetCDF. This is a standard, and this will help you to combine different sources for the same type of data. But in fact, when you want to build a solution, not only combine data, you need to be able to combine heterogeneous type of data, like where are the ships, where are the resources and the energy sources, where is the biodiversity, and what is happening on the environmental aspect on the coastline, for instance. Not only you need to be able to combine data, but when we want to build solutions, we have seen in eShape that we have tried to identify the different steps which are needed to build an Earth observation application. And in fact, you need co-design, you need, yes, to discover the data, to select the data source, to access the data. But then you need to go into the cloud or the computing systems and integrate all this data with technical solutions, with applications, artificial intelligence, whatever. You need to integrate all that, you build your solution, and then you deploy, and then you exploit. And you need standards not only at each of the level, but also to go through all these different stages. And standards enable fair data, services, processes, but also architectures. Vocabulary, semantics, I will not go into that, but it has been mentioned in the previous presentation. And why I talk about architecture here, because I was asked to introduce a little bit what is and the role of essential variables and analysis-ready data. My vision, it can be discussed because these are topics of research a little bit and discussion. Analysis-ready data, there is a working group in OGC working on that and working on a clear definition. My understanding is that it's the best data that can be reused by users that don't know so much about the complexity of the measurement, or maybe that will save some computing intensive and know-how required by post-processing, because you will build a product that can be massively reused to build several solutions. And the essential variables comes in the other direction. It comes from the scientists that say, these variables are impacting my system. And these are the variables I would like to be able to have accessible either from raw measurement or from analysis-ready data, because these are the ones that are needed from my domain. So in fact, both of them come from different directions. As I said, these are systems you need to watch and to look at in both directions. And of course, I hope that at some point here in between, this is where the different approaches will meet. Yep. I do not answer that. Can I minimize? Yes. So what is a standard? A standard describes requirement and recommendation that have been agreed in a consensus forum. This is the most important word when you talk about standards. It's the result of a consensus from as big as possible community, but diverse community usually. And you have several forums for to build standards, such as IETF, but also ISO, OGC, WMO. You have different forums. And to be useful, standards should be the best engineering practices. So we are happy to have best practices. It's great to have pioneers. Usually the best practices are related to a community. But when you want to merge data that comes from different communities, then you need to go towards standards which are recognized out of your community. So what are the standards for Ocean Digital Twins? The reference standardization bodies that are used in oceans are the ISO TC 211, which is the joint group for ISO for location data. The Open Geospatial Consortium, these standards are very used. Our standards are very used in many environmental areas. WMO and AHO. What you have to know is that we are not competing. There are many agreements and we try to work together. So for instance, ISO and OGC, you will see here all the works we have in common and the standards from OGC that have been endorsed by ISO. WMO also works with OGC and we have several standards which have been endorsed by WMO. And WMO IOC works work together via the GCOM, for instance. So I have been asked to work on licenses. So OGC directly doesn't work on licenses, but I have been working on licenses in my geo activities. And the idea is that the data should be as open as possible and as restricted as needed. So the licenses are very needed if you want to make your data usable and reusable, of course, because if you don't have any license, people don't know what they can do with the data. And they will not dare to build a business or to build anything on this data if they are not sure that they are granted and they can do it. The license can depend on the business model, but also on the licenses which are attached to the input data. So more and more data are open, yes, but they are very open with a CC BY, meaning that you are supposed to credit the data providers. And this is very important because we are using data that comes from research and researchers need the grants to be supported. And you have to credit CC BY or whichever BY, you have to make sure that you credit correctly the data because you want to support the researchers that provide the data you are using in your systems. So the Geodata Licensing Working Group, Law and Policies Working Group, has defined some guidances explaining which are the licenses that can be compatible with the data sharing principles that Geo is pushing. So you have some licenses that come from different groups and can really support a good data sharing. Data standard licenses enable machine-to-machine processing, and this is very important because with the artificial intelligence, the machines are very powerful, but they need to absorb and to consume a lot of data. And the more data you will make available and usable with a good license, which is machine readable, and the more the results of your artificial intelligence application will be good. And if you do not use so many data as an entry, you can think that the results will be poor. So I have put here just as a summary and abstract the different licenses which are standardized by Creative Commons. And but you have to know that the more you go toward the restriction, the less machine-to-machine readable it is, because very often the restrictions are expressed into a PDF, which is very difficult to read, not only for machines, but also for us, because we are not lawyers. And I think that the people who want their data to be restricted, but to be usable, have to think about that. And I heard that Creative Commons is considering to standardize more the restrictions. And I think that this could be a very good idea. And if you are involved in this work, congratulations, please support these efforts. So the takeaway is that Earth observation requires multidisciplinary skills, data from several providers, sophisticated technologies that are using a lot of data and need open data or very clear licenses, easy to use machine-to-machine. It requires data science skills and policies, and standards enable to make data, services, processes, architectures, vocabulary, semantics, operations over distributed resources, findable, accessible, interoperable, and reusable. And this is exactly what the digital twins need. Standards foster modular architectures based on open source, reusable software, components enabling rapid integration for collaborative solution. And I think that when we talk about digital twins, it's also that we are looking for. We look something that will accelerate the constructions of solutions. Thank you for your attention. And
thank you.
You have my contact here and the one from Piotr, who is more technical and can address also more technical questions if you are looking for that.
Thank you very much, Marie-Francoise. And we did also a poll while you were speaking, and I will present the results. You were asking, or we're asking the audience, are you using standards? And I'm sure you're delighted to see that actually most people are convinced that they are very needed. And we also have yes, but not in all developments. We have a strategy of where to use them or not. Yes, but not in all the developments. It depends on the developer, the time we have. So we have some positive attitude, but with some challenges to actually implement.
Yeah, I'm happy
yeah.
to see that there are nobody answered, no, they are useless.
Yes.
Thank you.
It's a calibration. So thank you again, everybody who participated in the poll. We really appreciate it. You see, we get some interesting outputs and some valuable information for the speakers and us who are organizing it. So with that, we move on to the next speaker, which is a citizen. It's Luigi, and he's going to talk about, is citizen scientist training relevant in achieving data quality and interoperability? So Luigi, a short introduction of yourself, and then you can start your presentations. The floor is yours.
Hi, thanks, Bente. Yeah, my name is Luigi. I am a scientist at Earthwatch in the UK. Earthwatch is an organization dedicated to citizen science, and I lead the research and innovation efforts at Earthwatch. In this presentation, I will talk about the relevance of the training in citizen science with respect to data quality and interoperability. So after a brief introduction, I will present the role of citizen scientist training in achieving data quality and interoperability. I'll analyze the challenges and limitations of this training, and I'll conclude with some consideration about the future. So this is an elaborate definition of citizen science. Let me read it because maybe not all of you are familiar with citizen science. So this is the work undertaken by civic educators and scientists together with citizen communities to advance science, foster a broad scientific mentality, and encourage democratic engagement, which empowers people in society to join the debate about complex modern problems. So often, citizen science involves people in data collection, and this is why this is relevant also for digital twins, because digital twins include data collected by scientists. So we need to understand what is the data quality and what is the interoperability associated to citizen science data. So data quality, of course, is the degree to which data meet the requirements for their intended use. So it doesn't need to be high quality. It just needs to be fit for purpose. We don't need to define interoperability because we had already from Marie-Francoise and Jay a lot about it. But let's see why data quality is important in citizen science. It is because it ensures that the data collected by participants are accurate, complete, and consistent. And interoperability is important because it allows this data collected with the quantified quality to be shared with other scientists and organizations. So this can help to improve the understanding of the data. So there are several things that can be done to improve data quality and interoperability in citizen science. So I'll skip this because this will be object of a poll that will appear at some point on our screens. So I don't want to spoil it. So let's see more in detail what is the role of citizen scientist training in achieving data quality and interoperability? But first of all, there are several aspects of citizen scientist training. The two aspects that are relevant for the topic today are data collection, which covers the specific tasks that participants will be asked to do, as well as the data quality standards that need to be met, and data analysis, which teaches participants how to analyze the data they collect and how to interpret the results. I just shared in the chat just before starting a link to the slides, because I will not cover everything that is on the slides, but you have the slides so you can see all the details later if you want. So how can training in citizen science help to improve data quality and interoperability? Well, there are several aspects that can be improved in training. So in particular, these are teaching participants about data quality standards, providing participants with the tools and resources they need, encouraging participants to participate in quality control activities, creating a culture of data quality, emphasizing the importance of data quality to the project and to the participants, using standards data and standard protocol, and providing clear and concise documentation about the data. So let me give you a few examples of successful citizen science projects that have used training to improve data quality and interoperability. The first one is Freshwater Watch. This is a project very close to my work because it's an Earthwatch project that collects data on quality of freshwater ecosystems. So this project uses very high standards for data quality. It provides training material and resources to participants. It offers online and in-person training workshops. It has a team of data quality reviewers and has a system for reporting and resolving data quality issues. So you can have a look. I included the URL. So there is a lot of documentation online. And when you start participating in the project, you go through this training as a mandatory step before being able to collect data. Another example is eBird. eBird is the largest citizen science project, which collects hundreds of millions of data about birds. Again, the project uses a standardized data format and provides clear and concise documentation about the data. And finally, another example is Galaxy Zoo, another project that put a lot of emphasis on data quality and interoperability. So you have the URLs of this project if you want to know more about them and what they do in details. So of course, there are challenges and limitations of the citizen scientist training. Let's see what they are. So first of all, cost. So training can be expensive, especially if it requires travel and the hiring of experts. Time, training can take time. Accessibility, it might not be accessible to all participants. Language, training might not be available in all languages. Retention, participants may not retain the information they learn in training. Motivation, participants may not be motivated to participate in training. And evaluation. It's usually difficult to evaluate the effectiveness of training as there is no one-size-fits-all approach. So there's the poll here. Well, all these challenges can be addressed, of course, and I'm not going through the details of this, but I will summarize them in a moment. Yeah. So concluding, citizen science projects rely on participants to collect data. Data quality and interoperability are essential for citizen science projects. Training can help to improve data quality and interoperability. Of course, there are challenges and limitations to citizen scientist training, but these challenges can be addressed, in particular by using online training models, offering shorter training sessions, making training relevant to volunteers, using interactive methodologies, providing ongoing support, and evaluating training and its effectiveness. So to finalize, let's have a look at the future of citizen science and data quality. So more and more people are interested in participating in citizen science projects, and the technology that is used in citizen science is becoming more accessible. Data quality is essential for citizen science projects. Without quantified quality data, the results of citizen science projects cannot be trusted. There are several challenges to ensuring data quality in citizen science projects, such as participant motivation and training, data entry errors, and environmental factors. These challenges can be addressed by using innovative technologies, such as artificial intelligence, and by developing better training methods. Mobile devices are becoming increasingly powerful and sophisticated, and they are making it easier for participants to collect data anywhere and anytime. Artificial intelligence is being used to develop new tools that can automatically analyze data and identify patterns. This makes it easier to identify and correct data errors. Online communities are providing a space for citizen scientists to connect with each other, share data, and learn from each other. This is helping to improve the quality of the data collected by citizen science projects. And finally, citizen science projects are increasingly aware of the importance of data ethics. This is leading to the development of new standards and guidelines for collecting and using citizen science data. So yes, this is a brief overview of the intersection between citizen science, data quality, interoperability, and training. Thank you.
Thank you very much, Luigi. I have noticed that the field is continuously evolving. Just since I started being a part of the citizen science community in 2016, and there's a lot has been happening. I did a poll this time as well, and Luigi's questions has been answered. I share the results with you now. So what have you done to improve data quality and interoperability in citizen science projects? Luigi asked. And of course, not everybody is involved in citizen science projects, but as you can see, Luigi, several are also. So training participants using standardized data format and providing clear and concise documentations about the data, and encouraging participating quality controls activities. All got scores, the last one the most. So thank you again for participating. Very valuable information for us, and fun to know where we all are. So with that, I thank you very much, Luigi, and we move on to the last but not the least speaker, Rebecca.
Yeah, sure.
Can you introduce yourself and start your presentation? The floor is yours.
Yeah, hey everyone, thank you for having me. I'm Rebecca Zitoun. I'm a postdoctoral researcher at GeoMar. I'm an ecotoxicologist and trace metal biogeochemist. But I'm here in this seminar for my in my role as the Ocean Best Practice co-chair elect, and also I'm one of the leading ECOBs in the Early Career Ocean Professional Network Program of the Ocean Decade. And today my talk is a bit different from the other speakers, because I was asked to give more of an inspirational talk, talking a bit more about ECOBs and their role in this topic. So today I will be talking about ocean practices, and meaning building inclusive best practices and standards. And And we've heard already that the ambition of the Digital Twins project is to really generate knowledge that drives progress forward through really extensive observations and the analysis of model data. And as Jay and the other speakers said earlier, generating this knowledge has to be done by following best practices, it has to be done by following standards, because that only then can we ensure and support the interoperability of the data that we produce and collect, right? And of course, the data itself has to follow the fair and care principles. And we have to use these best practices and standards to assure interoperability along the whole value chain, not just when it comes to obtaining the data and analyzing the data, but also when we produce products, when we produce services, and when we look at the actions that follow after this data, when we talk about the development of laws and the development of policies and management strategies, right? And that is something that's usually not really addressed very well. Because we usually look towards the bottom of that pyramid you see on the page when we talk about best practices and standards, and don't really look at the top. And in theory, it might sound really simple. We can only assure interoperability if we use best practices and standards, but in practice, it is a very complicated thing to do because there are a lot of various challenges that we need to address and that we are facing as a community. And they're actually all really described in Jay's paper that he published in 2021. They're pretty much summed down here on this slide in 5 categories. So one challenge is that ocean practices in general are undervalued and under incentivized, meaning that despite their necessity, as we described today, that we don't really publish complete methods and best practices. So it's not happening very much. So it's really complicated to put our fingers on best practices. Second, the marine science community cannot efficiently and unambiguously trace these methods that we are using to generate data and handle data and the information and then produce products. Sometimes we're just using methods without actually knowing where they come from, originally at least. Then we have linguistic and cultural barriers. I will come back to that in a second because that will be my main topic. And another challenge is that the methodology archives and management systems that we're using are strongly siloed and at times really inaccessible, so that different countries using different management systems and they're all not really compatible and interoperable. That really inhibits the interoperability of standards and best practices. And of course, that the concept of best practices and what a standard is increasingly ambiguous, meaning that people or initiative or programs really struggle when it comes to how do we evaluate or validate a best practices, or when can we say that a method is a best practice. And all these challenges really complicate our way of working and to achieve our ambition, right? But today I want to talk a bit more about challenge 3. So that's the linguistic and cultural barriers when it comes to standards and best practices. Because if we really want to have inclusive best practices, we have to increase our geographic and cultural coverage, which makes sense, right? That's also what the other speakers address. So we have to make methodologies accessible in different languages, not just English, which is at the moment the most accessible language. We also have to use different modalities, especially when you're working with people in Southern America or Africa that don't really have internet available. It's quite an issue, so that can't even download a simple PDF. So we have to start using other modalities to share and produce our best practices. And then, of course, we have to source best practices and standards from all regions in the world. As we all know, most of the standards and best practices that we're currently using are developed and adopted in the Northern Hemisphere, but they're not used in the Southern Hemisphere because they just have a regional different context. So we have to adapt them in different ways when we want to bring them to the Southern Hemisphere. And then secondly, we need to strive really to recognize the differences in identities that exist and sometimes even coexist. So we're talking about age here, we're talking about gender, race, ethnicity, nationality, socioeconomic backgrounds and disabilities, among a lot of other things. And we really have to recognize that these different perspectives that they really spark creativity and problem solving, and indeed make best practices way better and more sturdy if we include all these different backgrounds and identities. And it's critical that across all levels, when we talk from ocean decade activities to ocean decade programs, that those involved, that we really critically reflect on who's represented and has a voice in our initiative and in our program. And I specifically, just very shortly, want to touch on the age level, which goes a bit hand in hand with the professional experience levels that people have. And especially the importance of including ECOPs, so early career ocean professionals, because I'm one myself. And it's important to include ECOPs in the whole value chain of developing, using, adapting, and endorsing best practices and standards. And you might think, like, why should we involve ECOPs? Because they have the least experience of when it comes to their background and their science. And there are two main reasons. As you can see on the graph on the right from the Ocean Report 2020, youth below 35 years account for a significant percentage of ocean researchers. So they are the ones that are mainly in the field, who are collecting the data, who maintain the instruments, who stand in the lab, who analyze the data, who produce the models, who produce the products. So they're really important when it comes to keeping the scientific wheel going. So they really should be involved in all levels of producing best practices and standards. And second, when we look at the graph just showing here, again from the Ocean Report, it shows the clients and end users of data products and services provided by data centers. And we can also see here that one of the core users, again, are students. They are ECOPs. So again, ECOPs are largely producing data and they're using the data. But when we look at the actual involvement of ECOPs and the process of best practices and standard development and endorsement and adaptation, we can see that ECOPs are not appropriately recognized as really the intellectual source that they are and the workforce that they are. So what I'm wanting to really drive down today is that we want as a community to produce really inclusive best practices and standards, that we have to actively include ECOPs in the decision-making process and allow them to really have leadership roles. And we really have to move beyond that tokenism of ECOPs. So ECOPs really should be naturally integrated within every step of producing best practices in the process of doing it. And we need to provide them with tangible and impactful opportunities to lead and contribute as equal partners in the process. And just for you guys who do not know what I mean by tokenism, this slide is a really good example of what I mean to drive the message home a little bit, is at the UNOC, which was the United Ocean Conference that happened in Portugal last year, we had more than 5,000 participants that were registered for this really impactful conference, right? But if we look at the circle at the bottom of the slide, we can see that only 50 of these people that were registered were officially classed as early career ocean professionals. And this is less than 1% of the total attendees, right? And then if you break that down a little further, and look at more closely at the data, we can see that 95.3% of these ECOPs were from Europe and North America. So the diversity of these ECOPs was not really given. And we had, which was kind of good in a way, and we had 19.5% of the ECOPs were identified as females. But if we look again at the active involvement, and if the active ECOPs were actually actively participating in leadership roles, then we can come only down to 42%. So only 42% of the ECOPs that were present at this really important conference had speaking roles and leadership roles, which is actually quite sad. I know it's getting better, but sometimes it's just nice to have these values in front, just to realize what is happening. So again, if we want to do better as a community and develop truly inclusive best practices, we really have to reflect on who is represented during our decision-making meetings and who has a voice in these meetings, right? And the truth is, as with the UNOC, that ECOPs are largely left out, even though they are the ones who implement these practices in the field, and that they're probably then again, because they're using them, are most aware of the challenges and the issues that hold them back and how we can improve them. So I think as an ECOP myself, it's really important that we are included in this process. And I think to come back to the Ocean Best Practice System and what we are doing in our program, which is an endorsed Ocean Decade program, is we're doing it really well because we're trying to really address the issue of diversity and inclusion by really having a program that addresses all the stakeholders, because we realize that only collectively can we advance ocean best practices that are produced by the community for the community, right? And we're doing that by having workshops that are accessible for people all over the planet. We have our own ambassador program to bring ECOPs into our program and train them. I myself am an ECOP. I'm the co-chair of the Ocean Best Practice System. So we're putting ECOPs in leadership roles, and we're having task teams that are especially looking at diversity, equity, and inclusion issues and in coastal observation issues in under-resourced countries, which I think is great. And yeah, if you want to know more about what we're doing as a decade program, feel free to email us or to click on our website. And yeah, I just wanted to keep it real short. And so I end with that and I stop sharing my screen.
Thank you very much, Rebecca. Inspiring indeed. I can tell you that. Just coming from the Iliad Summer School with lots of ECOPs, as you call it, and very talented ones too. So indeed, there's a great potential that we can tap into for our society. Now, I will end the poll and share the results with you all for Rebecca's question. And I believe it might be the answer, I don't know, might reflect that people don't recognize the acronym. I suspect that might be the case. But anyways, they are ECOPs, so early career ocean professionals involved in your program or project in active capacity in leadership roles. And you can see there are some.
Yeah, that's good.
So not bad. But also positive, those who haven't or don't do it are curious to interested in exploring how to engage them. So thank you again for participating in the poll, and these polls will be included also in the report. So for you, the speakers, we collect this information. It's nice to follow up.